Welcome back. So far we have covered two examples on evaluating the derivative of functions using the power rule and some of the other basic rules. So guys, I'm back with another example which is slightly different than the previous ones. In this case, obviously you can see it looks like we are taking a product of two functions, one being a linear function and the other one being a quadratic function. Again, right now, in order to actually evaluate the derivative, all we know is how to evaluate the derivative of the form x to the power n, which is the power rule. Guys, later I'm going to be talking about some other rules, then we may be able to bring in some other rules to actually evaluate the derivative of this function. But right now, we have to make sure that each and every individual term is in the form x to the power n, and they are like either added or subtracted. Okay, in this case, there's a product here, so we don't know how to handle that product in terms of you finding the derivative. So guys, we have to first simplify this expression, and then we can probably see if we can use the power rule or combination of some of the other basic rules to find the derivative. So the obvious thing to do here is to kind of distribute this or multiply this out, and that's exactly what we are going to do, and that's exactly what we are supposed to do. So let's go ahead and do that. Multiplying this out, this is going to be, so I like to draw these arrows. It's up to you how you like to do it. Because I'm used to doing these arrows since I started learning this, I keep on doing it. So guys, it's going to be 3x to the power, x to the power 3. Then I have minus 4x. I do this times this and this times this, and then I do the second term, which is positive 1. So it's plus 3x squared, and then there's a minus 4. And then I look at this expression with 4 terms and see if there are any like terms. If there are any, then we combine them. If not, then we just leave it like that. So guys, in this case, we don't see any like terms. They're all different, right? There's cubic, there's square, there's linear, and then there's a constant. So that's it. I mean, we have this function simplified. It was not too complicated. The reason why I actually chose to do this example is that sometimes I have seen students, like when they look at this and they're like stressed because they don't have any direct ways of evaluating this derivative. So they're not able to figure this out. But just by doing a simple algebraic using a simple algebraic technique of multiplying through or distributing here, we can convert this into something that we can evaluate the derivative for. Now we can apply the rules that we have learned to find the derivative. These are 4 terms, so we can find the derivative of each individual term and then just combine them, and we'll have the derivative. So let's go ahead and do that. So derivative here, in this example, I'm not really even going to write all the d over dx notation, because now I have already shown you 2 examples. Now we should be able to do some of these things just by skipping some steps and quickly evaluating the derivatives. In this case, it's just going to be 3 times 3x to the power 2. That is the derivative of this, 3 times this. So let me put it in the parentheses because I still want to write some steps. And then minus 4, derivative of x is just 1, so I'm just going to write that 1. And then plus 3 times, this is going to be, guys, 2x to the power 1, so I'll just put it in the parentheses. And then we know the derivative of a constant is 0, so let me write that 0. Then moving on, simplifying these things, 3 times 3 is 9x squared, nothing really crazy. Negative 4 times 1 is negative 4. Guys, this is just 6x, and then we don't have to write the 0, and this right here is the derivative. Guys, if you like to write it in the standard form, which is like starting with the highest power of x and then all the way to the lowest power, then you can do some rearranging here. It's just 9x squared plus 6x minus 4, nothing really crazy. So guys, again, if you have a product, I mean, we could have a product of 3 functions here. You just have to multiply them through, and then you will get more terms, and you will try to find the derivative of each individual term, and using the power rule and using these basic rules, we can easily do that. So guys, this was 3 examples. I'm still going to show you a few more examples. I want to do some like application problems here as well. And then once we become more confident with these basic rules of derivatives, then we are going to jump into the product rule and the quotient rule and the chain rule, and then we can handle more complicated and complex functions. Guys, till then, you take care. I will see you in the next